Hello once again. How are you? I hope that you are bathing in the sunshine rather than sweltering in the humidity, which I think a lot of us are. I'm Rajan Datar, and welcome to this, the 6th of our weekly Summit Series webinars. In a moment, Professor Adrian Martineau will be in conversation with me to discuss the rediscovery of the importance of vitamin D, the so-called sunshine vitamin, for human health, and in particular, its potential role in preventing respiratory infections and non-communicable diseases. Drawing from his research, Adrian will explain how vitamin D has played a key role in immune function for centuries, and he examines its potential role in the fight against COVID-19, with a look at the ongoing research in this area and some early findings from the Covidence UK study. Adrian's recent experience with research in this area has focused on children living in locations throughout the world, including London, Lahore, Cape Town, and Ulaanbaatar, which is in Mongolia, because I've been. But first, a reminder as to why we are here. Because founded in 1917, West London Action for Children, WLAC, provides free counselling and therapy for vulnerable children and families in the London Borough of Hammersmith and Fulham and the Royal Borough of Kensington and Chelsea. It provides individual therapy to children, young people and parents, and family therapy, as well as groups for parents, children in schools, dads, and mindfulness groups. The COVID-19 outbreak has had a significant impact on feelings of isolation and health and social anxiety for these clients, with many living in cramped, poor quality housing. In this context, parents of younger children are often struggling with having their children at home all the time, feeling guilty that they aren't doing enough, and barely getting enough time to look after themselves. Teenagers are finding it difficult to motivate themselves with a lack of routine, ongoing workload and pressures, and missing friends as well. Fear and uncertainty about how long the virus will be with us for only serves to increase the anxiety and depression for our clients. And this has a slight connection with what we're going to be talking about shortly. So it's a great cause, which is always keen to encourage support and donations. And if you go onto the website, you can see recordings of previous sessions that we've done, including, I think, coming up, last week's chat with Dr. Benjamin Zephaniah, which got a great reaction from many of you. Right, and so to my special guest today, who is Adrian Martineau, the Clinical Professor of Respiratory Infection and Immunity at Queen Mary University of London. And just before I talk to him, don't forget that you can ask questions to him by pressing the Q&A button at the bottom of your screen. I'll see the questions coming up. You can ask them anytime. You won't be identified, so you can do it anonymously or whatever you want. But please do that. Okay, Adrian, how are you?
Good, thanks, Rajan.
Good, nice to see you. You're back, you've just been on holiday, if I'm not mistaken.
Yeah, just back from chilly fortnight in the lakes.
In the lakes, very nice. Were you taking...
It was like arriving in Spain, coming back to London.
Were you taking in the rays of sunshine?
Well, where they were to be found, we sought them out, but they were few and far between.
Right. And COVID, how's life been during COVID for you?
On the busy side, I guess from my job description, job title, you can imagine that COVID is pretty much in the in tray. I've been working, keeping the TB clinic ticking over actually, rather than on the front line. Been freeing up some time for my colleagues who've been working at the Royal London on that. But most of my time's been spent on research and setting up the research study that you mentioned in the introduction, Covidence UK.
Can I just ask you, before we go into the detail, and you're going to do a presentation for us of the key findings and everything else that I mentioned before, but I want to basically ask you, first of all, a bit like that program Life Scientific on Radio 4, I don't know if you know it, but when they get into the personality of the person they're talking to. So I do want to ask you, what got you into this area in the first place?
So I trained as a doctor up in Newcastle, and then I went to Liverpool and did a diploma in tropical medicine and hygiene. And after that, I went off to work in South Africa in government hospitals for a few years, and that's where I got interested in tuberculosis. So when I came back to the UK to do a PhD and the rest of my medical training, I was interested in working on TB, and I read an article in The Lancet, which I'll refer to in the talk actually, highlighting a historical role of vitamin D in treating TB. And that seemed interesting and worth chasing up. And so I spent quite a few years in the lab working out the mechanisms by which vitamin D modulates immune responses to TB. And then it was a case of really sauce for the goose being sauce for the gander. It seemed that vitamin D was good for other stuff as well, viral infections, and hence the work on COVID.
And actually picking up on the vitamin D aspect of things, when did that first happen?
Well, that was really through the TB angle. So becoming aware of this historic literature that, you know, as long ago as the 1850s, people were treating TB with cod liver oil, quite heroic doses of it, over at the Brompton Hospital, which was then the London Hospital for Consumption and Disease of the Chest. And it really struck me that that had been neglected, that sort of area of research being neglected since the discovery of TB antibiotics, which kind of eclipsed the power of vitamin D to modulate the immune system. But then with the emergence of drug-resistant TB, suddenly so-called host-directed therapies, or treatments that are aimed at boosting immune responses, have become more important. And so it's been given new consideration, really.
You are going to talk about the historical aspect, I know, in your talk, so we won't go too much into that. But for the time being, but one thing that has certainly happened is that vitamin D has been linked to something. And ADHD is another link that they make with vitamin D and how it could cure that. Is that right? Yeah,
that's right. I mean, until the 1990s, really, vitamin D was thought to be a bit of a one-trick pony. So essentially involved with calcium balance. But it was around the mid to late 90s that people started realizing that the vitamin D receptor, which is the molecule that transmits the signal from the vitamin D molecule to the genome, was actually expressed not just in bones, guts and kidneys, but in the brain, as you allude to, and the lung, and a whole range of other tissues, 38 to date. And that was really the beginning of a story that's really been rolling for 30 years now, trying to work out what effects vitamin D has on all sorts of other tissues other than its so-called classical actions in preventing rickets and osteomalacia.
Because the first time I came across you, I mentioned it just before, was in 2018, roughly, I think, when you had done a big study of how vitamin D could help with malnourishment in small babies, and you were doing that study in Pakistan, I think.
Yeah, that's right.
Getting super doses of the stuff, basically, weren't you?
Yeah, so that was a study we did with University of the Punjab, randomizing children with severe acute malnutrition to get high-dose vitamin D plus standard therapy or standard therapy alone. And we really saw some pretty striking positive results from that study, showing that the kids who received the extra vitamin D gained weight more quickly, but also highlighting that central nervous system link again, their development improved. So not just their ability to walk, which you might have expected from stronger muscles, but also even their language skills and their speech improved more quickly, hinting at this important role in the central nervous system.
Well, that was fascinating. I mean, I presume that's still ongoing?
Yeah, so we're doing that trial again, this time in a rather sicker group of children. The first study was done in those with children who weren't in hospital. The ongoing study is in hospitalized children, and we're really looking to see if we can show a mortality benefit as well as a benefit in terms of weight gain. Okay,
well, I've got more questions for you, so hopefully will the audience. But let's go now to your presentation about vitamin D and immune function. And you go on to talk about more recent evidence and obviously its connection with COVID. Over to you, Professor.
Okay, thanks very much, Rajan. So can I just check that that's displaying okay?
I can see that, yeah.
Okay, great. Good evening, everyone, and good evening especially to Heather. I hope you're watching and you're doing okay. So my topic tonight, as discussed with Rajan, is around vitamin D and its importance for human health in general, but in particular for its importance in immune function. And as a former West London child myself, I want to take you on a journey starting off in the West and moving you to my current workplace out in East London and Whitechapel in particular. And this is where I work at the Royal London Hospital, just outside Whitechapel Tube. And in front of the hospital, there's a statue. And that statue is of Queen Alexandra, who was the president of the Royal London Hospital it back more than 100 years ago, 1904. Now, many of you will know, of course, that Queen Alexandra was married to Edward VII. Perhaps less well known is her connection to her fellow countryman, Niels Freiberg Finsen, a Great Dane who was the recipient of the Nobel Prize in Physiology or Medicine in 1903. And this was awarded to Finsen in recognition of his contribution to the treatment of diseases, especially lupus vulgaris, which is the technical name for tuberculosis of the skin. And he developed a treatment with concentrated light radiation, which opened up a new avenue for medical science. And this contribution of Finsen's is immortalized in a frieze at the bottom of this statue, which I walk past on my way to work every day, which shows Princess Alexandra with Edward VII there in the skin TB treatment facility, which she paid for at the Royal London Hospital. And you can see here what was known as the Finsen light, which is essentially an arc light, which was generating high intensity ultraviolet B, which was then channeled down these tubes and directed at skin lesions of people who had tuberculosis of the skin. I don't know if the arrows are projecting, are they, Rajan?
Yeah, good.
Okay. And this shining with a very bright light on the skin lesions was curative. This, of course, was in the pre-antibiotic era, so there was no other treatment around for tuberculosis of the skin. And this was such a striking effect that a lot of people wondered how it might work. And the initial hypothesis was that ultraviolet B radiation in the light was actually having a direct physical effect on the TB bacteria, which are represented here by these pink rectangles. And it was actually disrupting their membrane directly and causing them to die. But this hypothesis was disproved by an interesting observation that was subsequently made, namely that if you shone very bright light onto children who had tuberculosis of the lungs, that also improved their recovery. Now, obviously, the lungs are buried deep within the chest, so any light rays that are hitting the skin won't penetrate the chest, and therefore they wouldn't be able to directly attack the bacteria. So the logical conclusion of this observation was that rather than the light having a direct effect in disrupting the tuberculosis bacilli, there seemed to be an indirect effect whereby the light was stimulating the synthesis of something, which then led to the destruction of the TB bacteria. So what this something might be was then investigated by Elmer McCullum in the United States in the early 20th century. And he did some very elegant experiments with looking at some rats that he had in his laboratory who had various nutritional deficiencies, and in particular, ones that had a combination of rickets, which is a disease of the growth plate of the bone, and a condition called xerophthalmia, which literally means dry eyes, but it's an eye condition that occurs with certain nutritional deficiencies. And he found that when he gave these malnourished rats a diet of cod liver oil, this cured both the rickets and the eye problem. But then he wanted to find out which element in the cod liver oil was responsible for these therapeutic effects. So what he then did was he bubbled some oxygen through cod liver oil, which has the effect of oxidizing vitamin A and getting rid of it. And he then treated the same rats, instead of with the full cod liver oil, by giving them cod liver oil which had been treated with oxygen and therefore had the vitamin A removed from it. And interestingly, what he saw was that this cod liver oil minus the vitamin A was still able to cure rickets, but it could no longer cure the dry eye problem. And he concluded that vitamin A deficiency was responsible for the dry eye problem, but that some other substance in the cod liver oil was able to cure rickets. And he wrote in a classic paper nearly 100 years ago now that the evidence set forth demonstrates that the power of certain fats to initiate the healing of rickets depends on the presence in them of a substance which is distinct from fat-soluble A. These experiments demonstrate the existence of a fourth vitamin whose specific property, as far as we can tell at present, is to regulate the metabolism of the bones. And seeing as vitamins B and C were taken, D became its name. Now, subsequently, vitamin D was shown to be made in the skin by the action of sunlight. And people put two and two together and thought, well, okay, vitamin D might be the active ingredient here, let's just give high doses of vitamin D by mouth to people with skin tuberculosis. And here's a picture from the Lancet back in 1947. On the left, you can see the face of a woman with skin tuberculosis before, and on the right, after a 2-week course of high-dose oral vitamin D tablets. You can see the effect is pretty striking.
Amazing.
However, back just 1 year later, one of the first randomized control trials ever done was to establish the role of streptomycin in treating tuberculosis. And then subsequently, with the development of other antibiotics, isoniazid, rifampicin, interest in vitamin D as a treatment for tuberculosis waned somewhat. And we just started treating TB with standard antibiotics because obviously they were pretty potent. So the evidence that giving vitamin D to somebody could help their tuberculosis perhaps suggested that vitamin D might be the way, or the middle messenger, if you like, in the pathway by which light led to improvements in patients who had TB. Now, this was all forgotten for about 40 years, but when I was up in Liverpool, I worked for a great guy called Peter Davies, who had read all of these studies and hadn't forgotten them. In particular, he used to work at the Brompton himself and was aware of this historical trial that was done in the 1850s, where cod liver oil was given to patients and shown to improve survival. And he took the hypothesis a step further and basically had the idea that vitamin D might not only be important for treating patients who are ill with tuberculosis, but it might also stop people who had dormant tuberculosis or latent infection, which affect about 1/4 of the world's population, from falling ill with active tuberculosis. And one of the interesting pieces of data that he highlighted relates to the pattern or epidemiology of tuberculosis here in the UK. And what I'm going to show you is a graph showing the incidence, which is the number of new cases of TB, 100,000 population per year in various different groups of people. So here's the incidence of TB in people who are born in the UK. And here it is among people who live in the UK but were born in South Asia. So you can see that they have a significantly increased risk compared to the UK-born population. Now let's look at those people who are born in South Asia and just look at those who arrived in the UK relatively recently, within 5 years. You can see that their incidence of TB is very strikingly higher than those who've been in the country for longer and those who've always been in the country. Not only that, but it's also higher than the populations who are still living in the various countries of South Asia. There seems to be something about immigration from the countries of Southern Asia to the UK that associates with an increased risk of developing TB. There's some sort of immunodeficiency that associates with migration. Now, the other thing that Peter did was he noticed that there was a pattern in what people's vitamin D levels did when they moved from Pakistan here to Lancashire in this graph. What he did was he measured their vitamin D levels and plotted them against how many months they'd been in the country. What you can see is that if you've arrived in Pakistan, from Pakistan to in the fairly recent past, you've still got a relatively high vitamin D level, but with the increasing amount of time you spend out of the sun, your vitamin D level falls. And so there seems to be here a correlation between the temporal fall in vitamin D status that's attendant on moving from a sunny country to a cloudy one, and the increased risk of reactivation of tuberculosis from its dormant state to its active state.
Can I just interrupt for 1 second and ask you questions about that, Adrian?
Yes, please do.
Why focus on the sun? There's plenty of other things that are different from being in Pakistan compared to being in the UK.
Yes, but his hypothesis related specifically to vitamin D because of some emerging laboratory data that was showing that vitamin D might have an effect on the cells which can control TB infection.
Okay, go, sure, yeah.
I take your implicit point. This is correlation. It's not by any means a scientific proof. It's more something in the background that led to more scientific studies being conducted. So his hypothesis that was really suggested by some of these observations was that vitamin D deficiency might be one of the causal explanations of why dormant TB infection might reactivate to cause active TB. So I'm now going to take you to another architectural jewel of the London NHS, to Northwick Park, where I then worked for another great boss, Rob Wilkinson, who I'm still working with in Cape Town. That's where he's moved. And Rob did this study, which was published in The Lancet some 20 years ago now, where he measured vitamin D levels in people who were rolling up to the TB clinic at Northwick Park who had either active TB or dormant TB. And he looked at the proportion of people who had vitamin D deficiency. And what he showed was that just over 2/3 of those with active TB were vitamin D deficient, compared with just over 1/4 of those with latent TB. And that showed a highly statistically significant association. And so we went on to hypothesize that vitamin D supplementation to people with dormant TB infection might stop them from succumbing to active TB. Obviously, this remains a hypothesis based on some observational correlative data. And to really test that hypothesis, you need to do a clinical trial. And so that's what I said about doing. We recruited some 200 people who had dormant TB infection. We randomized them by the roll of a dice using a computer program to receive either a dose of vitamin D or a dose of placebo, which looked and tasted the same but contained no vitamin D. We followed them up, and then we measured their immune response to TB bacteria. And these are the findings. First of all, what you can see here is a demonstration that the supplement worked in terms of boosting vitamin D levels. So you've got vitamin D levels here on the y-axis of this graph. The open circles represent those randomized to placebo, and the closed circles represent those who had the vitamin D supplement. You can see clearly that vitamin D puts up your vitamin D levels. You can't always take these things for granted. But here, what you can see is on the y-axis, the amount by which the TB bacteria grew in people's blood. This is how much they grew in the people who had placebo, and this is how much they grew in the people who were given vitamin D. You can see a modest but statistically significant reduction in the ability of TB to grow in people's blood. And that reduction was actually greater among those who had lower vitamin D levels to start with, which kind of fitted with our expectation. You would expect that a benefit of a supplement would be seen particularly in those who are deficient in that micronutrient to start with. So then the question arose, well, is vitamin D having this effect directly on the bacteria? Is it acting as some sort of antibiotic? Or is it stimulating the immune system to attack the bacteria? What we then did was we incubated bacteria with vitamin D, very simple experiment. You can see along the bottom of this graph here, increasing concentrations of vitamin D. And on the y-axis, you can see the numbers of bacteria. You can see that there's really no significant effect of the vitamin D on the bacteria if you don't have any human cells around. So it seemed that vitamin D wasn't having a direct effect, so perhaps it was having an effect on the immune response. And one of the molecules that we were interested in is a family of molecules here called AMP, which stands for antimicrobial peptides. And these are substances which are made by white blood cells and by the lining of the lung, which are negatively charged, and which can actually attack the cell membrane of bacteria and kill them. They're like essentially natural antibiotics, which our immune system is geared up to have. And we had some indication that these might be regulated by vitamin D. And so we tested this out in my own blood cells and those of 9 friends of mine, which we then infected in the lab with the TB bug and then treated with vitamin D. And we looked at the concentrations of one of these antimicrobial peptides, whose name is cathelicidin, but that needn't particularly bother anyone. What we showed is that in the absence of TB bugs, the vitamin D switched on production of this antibiotic substance about 100-fold. In the absence of vitamin D, TB actually switched off production of this antibiotic-like substance, which perhaps suggests that the TB is using this as a way of subverting the immune response. But when we had both vitamin D and TB present, we found that we were able to overcome that subversion of the immune response and restore the body's ability, indeed augment the body's ability to produce this natural antibiotic substance. And when we synthesized this substance artificially and cultured it with TB bacteria, we showed that at the concentration that we found in the cell, we were able to decrease the growth of the TB bugs by about a log, i.e. about 10-fold. So to go with some other experiments, which I'm not going to bore you with this evening, this provided reasonably conclusive evidence that one of the mechanisms by which vitamin D could boost our immune system and help against tuberculosis was by supporting the ability of the immune system to make these antimicrobial peptides. So could it be then that vitamin D might also make these antimicrobial peptides which could have activity against viruses? Now, there's obviously some suggestion of this by the very well-known observation that during winter and spring, we're much more susceptible to viral infections such as influenza and the common cold. Might one of the reasons be that this is due to low levels of vitamin D in the population that are less able to support basic innate immune responses to respiratory viruses? Well, to work this out in the lab, again, we took some of our own cells, cultured them with two different types of vitamin D. Again, the details I'll spare you. One's called 25-hydroxy, one's called 1,25-dihydroxy. We cultured our cells with these vitamin D metabolites, and we infected them with a rhinovirus, which is the cause of the common cold. And after 6 and 24 hours, we took out the fluids and we measured the amount of viral RNA, ribonucleic acid, in the cells. What we showed is summarized in this slide. If I just draw your attention to this checkered column, that shows the amount of viral RNA in cells which weren't treated with vitamin D. And these orange and red columns represent the amount of viral RNA that was present in those that were treated with the two different forms of vitamin D that we investigated. So about a 75% reduction with one of them and about a 50% reduction with the other. So it seemed like this vitamin D might be supporting immune responses that are protective against viral infection as well as bacterial infections. Now, of course, this is just a very reductive test tube experiment. We really, as clinicians, wanting to know, can vitamin D supplements actually reduce someone's risk of an acute respiratory infection? And I'm going to use this term acute respiratory infection to refer to any infection of the respiratory tract whose symptoms last up to 30 days. It's a standard medical definition.
Can I get... Sorry to interrupt. So in a sense there, you're getting close to establishing that vitamin D could be a cure for the common cold. Was that one of the things you looked at?
Not so much a cure, but a preventive intervention.
A preventive intervention. When people always talk about vitamin C and as being that thing, I mean, was this quite a radical discovery?
Well, it's only one letter down the alphabet, but it did upset some of the vitamin C enthusiasts. I mean, Linus Pauling in the 1970s was a big champion of vitamin C. The RCTs, or randomized controlled trials of vitamin C, and ultimately haven't shown major effects in terms of prevention, although there are subtle effects in terms of reducing the duration of a common cold, particularly seen in athletes. So what we're investigating here is the ability of vitamin D to reduce one's risk of succumbing to a common cold,
right,
rather than what Pauling and others were looking at, which was using megadoses of vitamin C to make a cold less severe and to make it go away more quickly.
Got it.
And so to test this hypothesis, again, a clinical trial was needed where you randomise people at risk of acute respiratory infections, again, to get vitamin D or placebo. You follow them up and compare the proportion who succumb to these infections over a period of time. And to cut a long story short, we did 3 such trials, and other people around the world did 22 such trials. And we wrote to them all in about 2016 and said, look, let's put the data together and really maximize our power and see whether this stuff works. And we identified these 25 trials that are done all over the world. And this is what we showed. So let me just explain to you what this figure shows. So this panel here in the middle is what's called a forest plot. And what it does is it illustrates the effect of an intervention on your outcome of interest. In other words, it illustrates the effect of vitamin D supplements on your risk of an acute respiratory infection. And each of these rows here represents a different study that was done. There are 25 rows in total. Now, there's a vertical solid line here, which aligns with an odds ratio of 1, and that's a line of no effect. And what you can see here is for each trial, there's what's called a box and whiskers. And the box represents what the average effect is, and the whiskers represent how certain we can be that that is the true effect. So if you see a study like this one here by my friend Carlos Camargo, one of the Mongolian studies, you can see that the box and the whiskers are firmly to the left of this central line, showing that there was strong protective effect. If you look at this study here, done by colleagues in Denver, US, you can see that the box and whiskers are almost to the right. In fact, there's a tiny overlap here, which means it's not quite statistically significant. So essentially, there are two take-home messages from this. The first is that if you put all the data together and you meta-analyze them, so pool the data, overall, there is a statistically significant protective effect. It's quite modest. It's around about a 10% reduction in risk, a 20% reduction in odds, but it's highly statistically significant. So overall, vitamin D does seem to modestly reduce your chances of getting an acute respiratory infection. But here's another statistic called the I-squared. And what this illustrates is quite a high value. You've got to take it from me. What it illustrates is what you can see with the naked eye, and it's a measure of what's called heterogeneity. In other words, it's a measure of how variable the results are across different settings. And what that high value there says is that there's a high degree of variation in how vitamin D performs in different studies. For example, here in Mongolia, it does really well. Here in Denver, it does not very well at all. And here in East London, well, all of these studies overlapped the zero, so it didn't seem to do very much in East London either. So how can we explain this? Because it's really quite confusing. Well, I think what we need to do is ask a question, go back a step and say, well, is it really plausible that everyone would respond equally to vitamin D? And in particular, let's go back. Do you remember our tuberculosis data showing that those who had the lower vitamin D levels responded better? Now, Einstein himself said that a scientific theory should be as simple as possible, but no simpler. And so we decided that perhaps it would not be unreasonable to hypothesize, and we hypothesized this in advance, that people who had low levels of vitamin D to start with would be more likely to benefit than those who had high levels to start with. And what we were able to do, because we had the raw data from all these 25 trials, was we were able to break them down according to people's baseline vitamin D level and test whether supplementation was more protective in those who had low levels to start with compared with those who had high levels to start with. Are you following me?
Yeah.
Okay.
Yep.
So here are the data. So what we have here is a table showing the effects of vitamin D, first of all, in those who've got a low vitamin D level, less than 25 nanomoles per litre. There are 538 people, and what this odds ratio shows here is 0.58. That's equivalent to a 42% reduction in the odds of getting a acute respiratory infection. So quite a big protective effect, highly statistically significant. But when you look at the people who have the higher vitamin D levels to start with, these are more numerous, you can see here that this odds ratio is much closer to 1, and in fact the 95% confidence interval spans 1. In other words, it's not a statistically significant effect, and that's highlighted by the fact that this p-value is greater than 0.05. So our hypothesis that vitamin D is more protective in those with lower levels to start with was borne out by this work. Okay, so one of the ultimate acute respiratory infections, COVID-19. Could it be that vitamin D has a role to play either in treating COVID-19 or in reducing one's risk of it? And this is a question which I addressed recently in an article for The Lancet, which came out just last week, vitamin D for COVID-19, a case to answer. And there is some circumstantial evidence, in addition to the generic data that I've shown you for respiratory infection caused by other pathogens, there's some specific data for COVID-19 suggesting that it might have a role. First of all, there's the interesting observation that in China and the Northern Hemisphere in particular, our first peak coincided with winter and spring. And this, in the Northern Hemisphere, aligns with essentially November through April, and associates with the lowest vitamin D levels. So, and then subsequently, we know South Africa is now going through their winter, and they're having a tough time of it at the moment. So, circumstantial observation there, perhaps suggesting some a degree of association.
Again, can I just, isn't there an issue though that and forgive my science here, but that the COVID thing survives better anyway in colder weather than it does in hot weather?
That's certainly possible. And then there are also major factors in terms of disease control policies. So in the UK, we locked down relatively late. In South Africa, New Zealand, Australia, lockdowns much, much earlier. And that's probably a major contributor to the different timing of the peak.
Okay.
So there are multiple potential explanations for this observation. But as a second interesting observation is that the risk factors that we know are for severe COVID-19 overlap very closely with those that we know are risk factors for vitamin D deficiency. What I'm talking about here is older age, having a greater weight, and also being of Black or Asian ethnic origin. And all of those factors are known to be major risk factors for vitamin D deficiency. And we know they're also risk factors for getting severe COVID-19 and for increased COVID-19 mortality. And indeed, we showed in one study that we did up in Newcastle that if you measure levels of vitamin D in people who come through the front door with COVID-19, those who end up in ICU had much lower levels of vitamin D to start with than those who escaped ICU, intensive care and ventilation, I should say. So we know also, and there's a study just out of Israel in the last couple of weeks showing in many thousands of people who had vitamin D levels measured, that those with the lower vitamin D levels had independently increased risk, not just of getting severe disease, but also becoming infected in the first place with the virus which is responsible for COVID-19, which is a SARS-CoV-2. And then just again in the last couple of weeks, some colleagues over at the University of Singapore have been looking at the effects of vitamin D in respiratory epithelial cells in cell culture that's been infected with SARS-CoV-2. So it's experiments akin to the ones we did with rhinovirus, but looking at SARS-CoV-2, and they've had some really striking positive results that vitamin D, albeit in concentrations which are somewhat higher than we have in our circulation, but it had some striking effects in terms of enhancing cells' ability to survive a viral challenge with SARS-CoV-2. So there's a sort of growing body of circumstantial and less circumstantial evidence that vitamin D might have a role in either the treatment or prevention of COVID-19.
Now, going back to when you mentioned the ethnic minorities, there is that obvious connection.
Yeah.
That in this country, that as you pointed out in your previous study, they're not getting enough vitamin D, if you like, or they're not compared to how their peers are in those countries, and therefore that is a very strong link. And that you're making a similar link here. Yes,
I mean there are a number of other reasons why people of Black and Asian ethnic origin in the UK may be at higher risk of COVID-19 and at higher risk of adverse outcomes. There's a whole raft of socioeconomic factors and other biological factors have been hypothesized. This is one of around 8 hypotheses that are circulating to explain the increased risk, and I suspect it isn't going to be any one of them. But the attraction of investigating this is that this is something that's readily reversible. So, as you've hinted, Rajan, the $64 million question here is, or $64,000 question: can vitamin D supplements reduce people's risk and or severity of COVID-19? And so since the outbreak, we've really been trying to answer this question by launching a big study, which I'd just like to tell you about in the closing slides of the talk. Broadly, there are 2 ways to answer this question. One is by doing observational studies, so basically enrolling people, asking them questions and seeing what happens to them. And the second is doing an interventional study or clinical trial in which we invite people to either get vitamin D or not, and then we compare their risk of getting COVID-19. Let me just describe those 2 approaches. In an observational study, we get a group of people who have already been taking vitamin D supplements, and we get a group of people who haven't been taking them. We follow them up over a period of months. We compare the proportion who get COVID-19, and then we adjust for a whole load of other risk factors to make sure that this isn't just explained by socioeconomic factors, which also associate with whether or not people take vitamin supplements. So this is an attractive approach because it's very inexpensive, it's very quick to do, but it's flawed because even with the best design studies, this is open to what is known as confounding. So essentially it's open to other associated factors which link in with people's risk of taking supplements, which can also potentially protect them against COVID-19. So a more robust, before I go into that, I should say that this approach can be taken beyond vitamin D. One could look at any other vitamin supplement, for example, vitamin C, zinc, selenium, other micronutrients which have been postulated to be important. And indeed, one can look much more widely. One can look at whether people are taking medications such as ACE inhibitors or statins or proton pump inhibitors, all of which have been implicated perhaps in enhanced protection. Or one can look at socioeconomic factors, look at housing, income, diet, exercise. The list goes on. And this list is, we're looking at 101 different risk factors for COVID-19 in our study, one of which is vitamin D supplements. And that's one of the reasons why we need 12,000 people to take part in the study, and we've got 10,000 now, so we're nearly there to really be well powered to get a good answer to this, but we're not quite there.
So you need 2,000 more volunteers.
2,000 more, yeah.
Yep, and there could be some in the audience. I've got a lot of questions here, which I want to ask you. But is that towards the end now of what you were going to say?
A few more slides, Rajan.
Yeah, sure. Sorry.
Let me just focus on that group who aren't taking vitamin D supplements already, because when we enrol them into the study, we potentially have a much more powerful tool to see whether vitamin D could work or not. Because what we can do with them is we can randomize them again with the roll of the dice. And half of them we can offer a vitamin D test to, and if it's low, we can offer them a supplement. The other half, we don't do that. And we can compare whether or not people get COVID-19. And when we compare those two proportions, that will then give us a robust scientific answer to whether or not supplements could prevent COVID-19. Because the randomization is a way of distributing these confounders or other risk factors for COVID-19 equally between arms. So if it is that perhaps higher socioeconomic status or particularly dietary factors or use of other micronutrients is protective against vitamin D, against COVID-19, those will be equally balanced between the two arms. So if we see a difference between the two arms at the end of the study, we can really nail vitamin D, and that can alter public health policy, and we can start putting vitamin D into the food system, which is what a lot of more enlightened European countries are already doing. So as we've mentioned, Rajan, the study is underway. It's called Covidence UK. It's a national study that we're doing with London School of Hygiene, King's, Edinburgh, Swansea, Queen's, Belfast. So right, pan-UK study. The way to sign up is to go to our website, which is Queen Mary, qmul.ac.uk/Covidence. And if you go to that URL, you'll find a load of information about the study. There's an FAQ page which can answer any frequently asked questions that others have asked us. And then if you click forward, the study involves completion of a questionnaire. It takes about 20 minutes to do the baseline questionnaire. It's pretty detailed. That's because we really want to nail down those risk factors in as much detail as possible. And then thereafter, it's around 5 to 10 minutes each month with questions about whether or not you've had symptoms of COVID-19 in the last month and results of any tests you may have had. So if anybody is watching and is interested in taking part, you have to be age 16 or more. It doesn't matter if you've had COVID-19 already or you haven't, or if you don't know. It doesn't matter if you're taking supplements or not. We need people in all of these groups to take part and help us to answer these scientific questions. And so that's the end of my talk.
Adrian, thank you so much. That's absolutely fascinating. There are, I say, lots of questions here. I mean, one thing that I suppose you're very keen to say is this is not a wonder drug. It's not a panacea. You yourself mentioned there might be 100 plus other factors which also have to be taken into account, which could also reduce the risk of COVID. So, yeah, in a sense, how excited are you about this? I mean, how big a deal could this be?
Well, I think it could be a very big deal because even a modest effect, by which I would mean something around the 10 to 20% reduction, could have a massive impact when we're talking about something that's so common and so devastating. And the reason I'm excited is because if we do show an effect, it's almost certain to be cost effective from a health economic perspective. You know, it costs around 10 euro cents in Germany to provide vitamin D fortification for one person for a whole year by in bread. Now, if you could reduce hospitalizations for COVID-19 by 10%, reduce mortality by 10% for that tiny cost, would actually be a massive story. It doesn't have to be a magic bullet like a vaccine to have a public health impact. I think, obviously a vaccine is going to be something that we're all waiting for, we're all excited about, but we have to be realistic about what effects that vaccine is going to have. First of all, not everyone's going to have it. We know there's a lot of vaccine hesitancy out there. Secondly, we know that for a flu vaccine, it's got limited efficacy, particularly in people aged 70 plus. It might have 70 or 80% protective efficacy. We know that nutrition can actually boost vaccine efficacy as well. So I don't think there's going to be any magic bullet for COVID-19. A vaccine is obviously going to be more potent than a micronutrient, but everything's got its role to play. This is super safe, it's non-toxic, it's inexpensive, and it's worth a shot.
Okay. I'm going to just fire through these questions. Some of them relate to what you just showed us, others refer to others. So forgive me if they sound a bit random. But anyway, and you did refer to this, someone asked, and do you think bread, forgive the child outside, do you think bread and other foods should have vitamin D added to it by the food authorities?
One word answer, yes. But it's not uncontroversial. So there are sort of civil liberties issues which a lot of people will raise. We've done quite a bit of qualitative work on this, and it's actually quite striking. Around about 50% of people will express concerns about not wanting their food to be tampered with. These are similar arguments that you get when talking about fluoridation of water.
Yeah. And
it may be that rather than a mandatory fortification policy in the UK, voluntary fortification of certain products, which is already starting to happen. So seeing vitamin D fortified mushrooms, vitamin D fortified milk, orange juice starting to come onto the market. That may be the way to go. But I have to say, that's really not going to reach a lot of the people who are at highest risk of deficiency. And the countries that have really succeeded in eliminating deficiency, eliminating rickets, Finland, Sweden, Germany, are those where vitamin D is just being put into foods without labelling further. In the US, for example, the land of the free, the vitamin D has been added to all milk products for the last 60 years. Okay.
Now, you did mention different types of vitamin D. Is there a certain sort we should be taking then?
Yeah, so there are two sorts, vitamin D2 and vitamin D3. Vitamin D3 is the sort that we make in our skin, and it's the sort we eat when we eat oily fish. In fact, oily fish get it from eating plankton, who make it from the sun. So all vitamin D comes from the sun in the first place. That's what's available in most supplements. People who are vegans, that can be a vegetarian. There's a vegetarian form of that as well, but not a vegan form. People who are vegans will want to have vitamin D2, which is made in lichens and fungi. That's a bit less effective in boosting vitamin D levels, but you can just take a bit more of it, and it's not dramatically less effective. But given the choice, I'll probably go for vitamin D3. It's made from sheep's wool, from sheep that aren't slaughtered. They're sheep from the wool industry, and so it's okay for vegetarians. It's just made as a byproduct of the wool washing process.
I read somewhere that you can only really get 10% of the vitamin D that you need from food as such, that the other 90% has to come from other sources. And I presume they meant sunlight by that, or am I wrong there?
Yeah, so sunlight is how we're designed to get it, really. In our ancestral state in East Africa, sunshine is plentiful. And if you look at vitamin D levels in people living in the tropics, they're averaging around 100, 150 nanomole per litre. If you measured vitamin D levels on the tube in April, you'd be looking at around 25 or 30 nanomole per litre. So we've got about a quarter of what we're evolved to have living at 51 degrees north, which is where London is.
And the supplement...
You can get more if you eat a lot of fish. So in the Nordic countries, people having cod liver oil, they're eating oily fish several times a week. So if you do that, you can get enough vitamin D, but then there are potential issues with having too much heavy metals.
Sorry, I interrupted you. But the supplement can actually make up for the lack of it in whatever the source is.
Yes. So the government recommends 10 micrograms. That's 400 units a day, and that will sort of prevent the most dire manifestations of vitamin D deficiency. Personally, I think one could be a bit more generous, around about 1,000 units or 25 micrograms. That's still 1/10 of the lowest toxic level that's ever been recorded.
Well, that was a question as well. Can you overdose on it?
You can overdose. You'd need to take, the lowest dose at which toxicity has been observed is 10,000 units a day. That's, but a safety factor of 40% has been applied to that. So the government recommends that the nobody takes more than 4,000 units a day as the safe intake level. And what they're recommending for people is 400, so they're recommending 10 times less than that. And personally, I think you can be a bit more generous going for around 1,000 or 25 micrograms, 1,000 units.
But there have never been long-term tests on people who've taken that amount over a lifetime?
Not over a lifetime, no, just because clinical trials are so expensive and it's so hard to follow people up. The longest clinical trials have been done in this are really not much longer than 5 years.
And you say toxic, what could happen to you?
Yeah, so if you really go overboard, it's a fat-soluble vitamin, so that means it can build up in your fat and muscle. The major complication is that you can then absorb too much calcium from your diet. That puts up your calcium levels in the blood. That makes you then make calcium crystals in your kidney, and you can end up with renal failure. You don't want to go there.
Okay. Another question, was the data that you're referring to, was it sex disaggregated, i.e. did they find a difference in the response to vitamin D in women versus men?
So we did look at that question and there was no difference.
Okay, that's nice and simple. Well, this question refers a little bit to what we were talking about. I've read that, this person says, I've read that vitamin D supplements don't have much of an effect on blood vitamin D levels. Do we need to get more sunshine or can we rely on supplements? Kind of what I asked as well.
Well, supplements do have a massive effect on levels if you take a big enough dose. So there's a linear relationship essentially between how much you take and how high a 25D level you make. So as a rule of thumb, if you're taking the government recommended amount, that's 10 micrograms, 400 units, 97.5% of the population will be above 25 nanomoles per litre. If you take around 1,000 units, what I was recommending, you're getting about the same proportion above 50 nanomole per litre, which is, I would say that's a better place to be.
So to answer,
that's actually quite modest. There are a lot of hyper enthusiasts who would say you need to be at 100 nanomole per litre plus.
And just to clarify, to answer this person's question, when he or she says, do we need to get more sunshine or can we rely on supplements? You're saying we can rely on supplements.
Well, yeah, I mean, if you're in the UK, you can't make any vitamin D from sunshine between October and April. The reason for that is because of our latitude and the angle at which the sun comes through the atmosphere. It comes in at too oblique an angle and the UVB is filtered out. You're not going to make any vitamin D from sunshine in the UK for those 6 months of the year. So the half-life is about a month. So every month after October, your vitamin D level falls by 50%. So you really do, if you want to keep your level up, you need to take a supplement over the winter.
Okay. Now this question, and the one after, I suspect it's from somebody who is medical or a scientist, and he may have to translate it for the rest of us. But he says, this is really interesting. Baseline vitamin D levels is a great point. I was thinking this from the start of your presentation. Are we only reversing mild acquired immune suppression with vitamin D? Because of a relative vitamin D deficiency, I think that's a yes, based on what you've just said, as I write. Is there evidence of genetic variation in receptor response to vitamin D that don't let us personalize vitamin treatment in infection? I apologize to the person who sent the question, but do you understand what he's saying?
I understand exactly. The first point is yes, 100%. I think essentially vitamin D deficiency is an unphysiological state. We're not designed to have vitamin D levels which are low. We're designed, we evolved in equatorial Africa, and we're meant to have levels in the 50 to 100, possibly slightly higher nanomole per litre range. So we're essentially restoring natural physiology, and we're restoring our normal immune function and physiology by bringing levels up to those which are seen in the tropics. Second question around genetics is a really interesting one, and the answer to that is also yes. So in our study, one of the studies we did, which is out in the Lancet 2011, we looked at whether people with particular mutations in the vitamin D receptor were more responsive to vitamin D. We found that there was a mutation in the vitamin D receptor that conferred heightened responsiveness. So yes, there is a significant amount of genetic variation in how well people respond to vitamin D. But the fact is, at the end of the day, it's very expensive to genotype people. So we're not saying that people should be genotyped and that vitamin D supplementation should be targeted in this way. But doing these studies can provide some mechanistic insights into why some people respond better than others. Okay.
And the same person, again, forgive me, is there evidence that vitamin D could modulate pulmonary vascular endothelial platelet interactions and increase thrombosis in the microclot phenotype? Again, please translate, and is it a good question?
Yes, it's a great question. So, and it relates to COVID-19. So the writer is alluding to one of the features of severe COVID-19, which is what's called coagulopathy. In other words, problems with blood clotting. And he's asking, or she's asking, whether or not vitamin D can correct problems with the coagulation cascade. And the short answer is yes, but it may be an indirect effect rather than a direct effect. And that effect is mediated potentially by a system called the renin-angiotensin system, which I think your writer will recognise. And if they want to drop me an email, it's a.martineau@qmul.ac.uk, and I'd be happy to provide chapter and verse.
Fantastic, fascinating discussion, meta discussion from the rest of us. Right, can you test how much vitamin D you have in your body?
Yes, you can. It's quite easy to do. You measure a form of vitamin D called 25-hydroxyvitamin D. And there are some very accurate postal tests available, actually. If you just type into your web browser vitamin D NHS Birmingham, it takes you to an NHS lab that provides a postal vitamin D kit. You basically get a small sheet of blotting paper through the post along with a lancet. You prick your finger, put on 4 drops of paper onto the blotting paper, put it back in the post, and within a week they'll email you back your vitamin D level. And
that's free?
It's not free, it costs £22.
Right.
Which is similar to what it costs the NHS. And so the GPs and in fact across the NHS, really people are quite reluctant to measure vitamin D status because it is pretty expensive and because it's actually very safe and cheap just to take a supplement. But I know from people want to know their personalised vitamin D level, whether it makes sense for them individually to take it. So I think that's a natural. It's a natural thinking response to have, and if that's the way you want to go, then that test is available. But it's quite hard to get through your GP. So if you want to shell out. And
over the course of a year, I mean, how much would it vary anyway?
So again, it depends which part of the UK you're living in. So if you're right up North Scotland, the amplitude of variation is pretty high. It might vary by as much as 30 nanomoles per litre. If you're down in the south coast, it might be something near 15 or 20 nanomoles per litre. But people do have set points. So, and this relates to the question about genetics. There are some people who are genetically predisposed to have higher vitamin D levels than others. And so people fluctuate around a set point, which is different for different individuals.
Okay. I've got a question. Is it true that the use of high factor SPF sun creams to protect skin reduces the effect of vitamin D from the sun to a dramatic extent?
Yes. So if you put on sun protection factor 50, that basically blocks ultraviolet B reaching the dermis, which is where 7-dehydrocholesterol, which is the vitamin D precursor, sits. And so that will basically reduce your cutaneous vitamin D synthesis to nothing. And that's really one of the reasons I'm more into supplements than sun. One, because sun won't work for 6 months of the year. And two, we know that ultraviolet B in sun gives you skin cancer. And melanoma is still killing thousands of people in the UK each year. So be safe, use a sunblock, take a supplement, then you can have the best of both worlds.
Don't rely on the sun for your vitamin D. Find other sources because it's risky for that reason. Okay.
Well, a bit of, safe sun is fine, and that will make a bit of vitamin D, but don't get burned.
Okay. Somebody who's a vegetarian and says, I found Adrian's description of which vitamin D is suitable for vegetarians a bit contradictory and confusing. Could he please be a little clearer?
Okay. Well, this arises out of my understanding of the difference between vegetarians and vegans. So my understanding is that if you're vegetarian, you're happy to eat eggs and honey and other products which come from an animal that don't require it to be slaughtered. And that's why I say that the vitamin D from sheep's wool is vegetarian approved. It's been approved by the Vegetarian Society. So basically what happens is the wool is washed, lanolin comes off it. That lanolin is then converted to 7-dehydrocholesterol in a chemical process, and then light is shined on it to make vitamin D. If you're a vegan, my understanding is that's not acceptable because it's an animal-derived product, and for that you need to go for the D2, which comes from mushrooms.
Okay. A few more questions. I've read that vitamin K, so somebody should be taken with vitamin D for it to be effective. Is this true?
Yes, so there are a couple of cofactors that are under discussion with vitamin D. One is vitamin K, one is magnesium. I haven't really seen convincing evidence that either of them is particularly needed. The third one that gets discussed sometimes is vitamin A, and that's potentially an antagonistic relationship. So there's some evidence that vitamin A and vitamin D compete for a molecule in their signaling pathway called retinoid X receptor. Some evidence that people with high vitamin A levels can suffer some consequences of D deficiency and vice versa. And indeed, historically, if somebody had vitamin D toxicity, they were treated with megadoses of vitamin A and vice versa. So there might be a bit of competition between those two.
It occurs to me that the antibiotics clouded or slowed down the discovery that vitamin D could be this effective. Is that fair?
Well, I guess they kind of made it forgotten, and I guess that was really one of the reasons I called my talk rediscovery. You know, there was all this evidence, and there was a load more that I didn't present around. You know, people using cod liver oil in the 1930s to reduce industrial absenteeism. You know, this was something that was in the 1950s. Cod liver oil was widely given to school children, but then it just kind of get forgotten. And I think that's partly the result of antibiotics, partly the result of better vaccines. And then partly there was a scare in the 60s around a few children who developed a high calcium level in response to high dose vitamin D. And people got nervous about it, and then it sort of fell out of fashion.
And what you also, just to finish off on that, what you're also saying is that we have natural antibiotics in us, which vitamin D can activate.
Yeah, so our cells, particularly the cells lining the lung and particular white blood cells of the immune system, make these substances in response to challenge with viruses or bacteria. But they need an extra factor to support the synthesis of these substances, and that factor is vitamin D. So it's not that the vitamin D is directly antimicrobial or antiviral, it's providing a support, basically restoring a natural part of the immune system which allows it to function optimally, a bit like putting oil in a car.
We're going to wrap up in a minute. It's absolutely fascinating, this. I do want to ask you, just in terms of how this trial, the COVID thing goes, what's the timeline that you've got in mind?
So the timeline for the observational study is that tomorrow morning we're doing a download for the first, what we call cross-sectional analysis. So that's looking at the first 10,000 people, looking at their risk factors and whether or not they've had COVID-19. The second phase is doing the prospective observational study, so following people up without intervening. And then the clinical trial is going to take place over this winter.
So in your ideal world, what position would we be in say 2 years' time?
Well, in the ideal world, I think my ideal position was that we wouldn't need to have vitamin D because we have a really great vaccine.
Okay.
But speaking more realistically, I think we're going to have a vaccine that's pretty good. COVID-19 is not going to be eliminated. It's going to be with us for a while. And we're going to need to look at a suite of measures which are going to be complementary to minimize our risk of getting it. And vitamin D might be one of those.
Okay. Well, can't quite answer that question. Oh, one thing. Are there, if we're going from like all these different things that vitamin D can affect, from malnutrition to COVID to whatever, I mean, other things like dementia, for example, I mean, could it have an effect there?
Yeah, I mean, people are really looking at vitamin D in pretty much every biological outcome under the sun. And the funding agencies have really got vitamin D fatigue now, I think, a bit. It's quite hard to get vitamin D research done because people are saying, well, come on, pull the other one. There is a bit of data on dementia, but it's quite hard to tease apart cause and effect because particularly in advanced dementia, people do tend to spend less time outdoors. And so you get a chicken and egg situation. Is it factors associated with dementia that mean people get out of doors less, and that causes low vitamin D levels? Or could the vitamin D levels be contributory? There's an association for sure. Whether or not it's causal is a moot point. There are ways of addressing that. Studies called Mendelian randomization studies. Again, if anyone wants to contact me about that, I'm happy to do chapter and verse.
But certainly the causal thing does come up a lot with any of these things, isn't it? You know, are we getting chicken and egg wrong way around, blah, blah, blah.
Well, yeah. And ultimately, the only way to unpick it is with a clinical trial. Unfortunately, they can't always be done. So, for example, there's a big story around vitamin D and multiple sclerosis, but to do a trial of vitamin D to prevent MS, it's got to have hundreds of thousands of people in it because of the lower incidence of MS. So that's probably a study that's never going to be doable, and we have to rely on other types of evidence. I mean, there's never a clinical trial done to show that smoking causes lung cancer, but we accept that as a causal relationship. Randomized controls trials aren't the only way to show causality, but when a hypothesis is testable via trial, people do expect them to be done, and that's why we're going about it.
Okay, I want to ask you just one question as well before we go. There's one more question, but I really apologise for this, but it hasn't come up on my. I don't know if you've got the Q&A there, Adrian.
I haven't, no.
Sorry, it's a big picture question away from vitamin D, but I can't quite get to it. And I apologise for that. But I want to know. I mean, are you on Sage?
No.
Right. I just want to ask you lastly. What have you thought about the role that scientists have had to play in this last few months? I mean, have you wished that you were there, or are you glad that you're not up there? What do you think?
Well, I don't think my expertise is right to be on Sage, because I'm an immunologist and a clinical trialist, but I'm not an epidemiologist. So I'm like everybody else, I'm an armchair epidemiologist now. My personal feeling was we should have locked down earlier. And I think that was my feeling at the time, and I was encouraging the university to take preemptive action on that. I told my group to go home 2 weeks before lockdown, and I think that's been borne out. I think the more laissez-faire approach taken by the Swedes and by the UK, the so-called herd immunity approach, has really not been vindicated. I think that if we'd had more aggressive testing, we'd probably be on a trajectory that's closer to Germany's than it is than we have at the moment. But all is not lost. I think if we can ramp up testing and observe social distancing, I don't think a second wave is necessarily in the post, but we have to be super vigilant.
But do you think scientists have been put in a slightly awkward, invidious position by politicians, or do you think science has stood up for itself, or what do you think? I won't get too controversial.
I have to be applying the wall and Sage. I mean, I think the government may be trying to hang some of the scientists out to dry, and I think some of the scientists are going to react badly to this, and perhaps say that they pressed for an earlier lockdown. We'll have to see. There was a hint of that in some of the special committee hearings a couple of weeks ago, and I wonder if that's a narrative that's going to be emerging in the months ahead. That might all come to fruition. Now, you've very generously given your email address to people if they want to contact you with specific questions. So that please do. I mean, definitely a massive interest in what you've been saying today. I think it's absolutely fascinating. Let's see what happens. But for the time being, Professor Adrian Martineau, thank you so much indeed for joining us today. It's been a great pleasure. Thanks for the discussion, Rajan. Really enjoyed it. Now, I should say before we go that I need to remind people why they are watching this, why Adrian's come on for this, because we want donations. We want to encourage people to give money to WLAC. Greg, if you're there, you can show us this. Yes, there you go. How you can contribute by text. Benjamin Zeffner asked me this very great question last week, which is if you haven't got a bank account or your phone isn't attached to your bank account, how does it work? And I couldn't answer him. I'm not sure if anyone can. But anyway, this is the way that you can do it, which is you can text Summer Series 3 if you want to contribute £3. You text that to 70085. Similarly, if you want to text £5, you text Summer Series 5 to the same number and donate £5. So please do that. I should also say that on the 25th, the next and last talk of this series, we have Anne Longfield, Children's Commissioner, who's been in the news today. This whole issue about kids and they should be at school, and that's the most important thing that we can possibly do in this current situation. All that, I'm sure, will come up. She is talking to Katie Razzle, and I want to thank you all for watching. I want to thank Adrian again, and join us, or Katie, anyway, and me, I'll be watching, for the next one. Bye-bye.